So liquids and solids are the next topic to talk about. And so let's talk about how liquids can exist in terms of all these intermolecular forces. So first of all, the intermolecular forces that you have going on allow liquids to be more ordered, more stuck together than a gas. And as a result of that, you can have the particles stuck together, attracting more, as opposed to gas, which is all over the place. And for gases, in order for them to be able to stick together, they have to be close. So for liquids, them sticking together is the only way they can be together. So that's what keeps the molecules together. And of course, all the intermolecular forces we've talked about before, hydrogen bonding, dipole dispersion, are needed for this. Now, because a liquid has the particles stuck together, what that means is that it can behave in a particular way. So, for example, when you have the liquid in a container and they're all kind of stuck together in some way, they do move around a little bit. So as a result of them stuck together, they can move together as a group, and them sticking together as a group allows them to flow. And they can then assume the shape of the container. Now, the stronger the intermolecular forces that the particles have towards one another, the more they'll stick together. And so the difference between, like, say, water and honey is all because of the intermolecular forces. The intermolecular forces in honey are clearly greater. That's why it's thick and it flows very slowly. Whereas in water, it sticks together, but it flows a lot more evenly and easily. Because these particles are stuck together, they're stuck together better in a smaller region of space, they end up being more dense. So most liquids are about 1,000 times more dense than a gas, and that's a significant amount. Because the gas particles are all over the place, you can squeeze them down a lot. But for liquids, they're already very close together. So liquids can only be really compressed about 4% of their actual volume. If you try and squeeze on a liquid, you end up pushing it as opposed to squeezing the volume that it takes up. And that's the reason why we put, like if you had water in a hose and you blow air through one end of the hose, it shoots out the other. Because if you're trying to compress it, it won't compress much, it'll be pushed. Surface tension, a really interesting and important idea. Surface tension is the tendency of a liquid to, because they attract each other, to shrink the area that they are in as much as possible. And it just allows liquids to clump together. And this is the reason why it is that insects and leaves and things like that can float on water, and the reason why you have water droplets, like I show you here in this picture. And again, why is that? Those intermolecular forces, for example, with water, are so strong that they hold together, and it prevents the force of, say, a leaf or an insect to break that force of attraction, and so it literally holds it up. And for a droplet, if you think about this picture on the right here, water is polar, a leaf isn't polar. If anything, they have sap, which is oily. And so as a result, that's not a compatible environment. So the only thing it's compatible with is each other. So the water stays together into one little droplet. Again, why is that the case? Those intermolecular forces pull the molecules together.